Now we will start with chapter 3. Chapter 3 is talking about expression and interactivity. The first section is talking about CN object. So CN is the standard input object. It's the same like cout in the sense that it requires IO stream file. So we need to write include IO stream to use CN, sorry. And it's used to read the input from the keyboard. So we write CN and we use this with the CN. So this CN will direct the input to some variable. So the input will be stored in one or more variable. Let's take examples. So again, we will include IO stream for two reasons. One reason is because we want to use cout. Another reason is we want to use CN now. So here is example. We define three variables. We make output statements. This program calculates the area of a rectangle. And then we ask the user what is the length of the rectangle using cout. After that, we use CN and we use this directive command in the other side of this in the cout. So in the cout, it was pointing to cout. In the CN, it's pointing to the variable name. So we want to read input and store it in length. That's why it's pointing to the length. And then we write another command, what's the width of the rectangle? We make CN and it's pointing to the variable width. So we read the length and the width from the user, and then we do some assignment for the area, and then we print the area. So this is how we can write CN. So the program will print some statement and will stop here because we have CN. So when we have CN, we'll stop and wait for the input of the user. If the user enter 10, this 10 will be stored in length. And then again, we'll print another statement and make CN. The program will stop here waiting another input. If we enter 20, this 20 will be stored in this variable width, and so on. So CN convert the data to the data type that matches the variable. So here we have int height, a variable of type integer. So if we read height, whatever the user is typing will be, the computer will try to convert it to integer. So this is what's meant by this slide. So displaying a prompt, usually before you ask the user CN, you need to print some statement asking the user what to write. Like for example, cout, how tall is the room? And then you write CN and ask the user for input. So you should always use cout before you use CN, just to let the user know what he has to input. We can use more than one variable in one CN statement. So in this example, CN height and then width. It's like we want to read the height from the user and then the width. So multiple values from keyboard must be separated by spaces in this case, and the order is important. So the first value that the user will enter, it will be stored in height, and then the user makes space, and the second value will be stored in width. Let us take example. So this is the same example like the rectangle area like before, but here the only difference is that we wrote for the user that we want you to enter the length and the width separated by space. So he will enter 10 space 20. So the 10 will be stored in length and 20 will be stored in width, and then he will calculate the area and print it. So we can make more than one input in one CN statement. Another example, we define three variables. First variable of type int, second variable of type double, third variable of type character. So we ask the user to enter an integer and a double and a character, and we read the three variables. So we read all, fractional, and letter, and we store the all. We print the all and fraction and letter. So we ask the user to enter three values in one cn statement. So here the user will write 4 and it will be stored in all. 5.7 it will be stored in fractional, and b will be stored as a character in the variable letter. And when we print them, they will be printed in this way. So this means that we can read integer, we also can read double, we also can read character. Mathematical expressions. So mathematical expression is some expression like this. It's like we can create mathematical expression using operators and some variable names or some literals. So this is example of expression. This is also another example of expression. So expression can be a literal, a variable, or a mathematical combination of a constant and a variable, and it can be used in assignment or a cout. Here we are using mathematical expression in assignment. We want to assign the value to the area, and here we're using mathematical expression in the cout. It also works. So in the mathematical expression, we should know the order of operations. So the most important operation is the unary negation, but this is we know by default. The second most important operation is the multiplication, division, and modulus. They have the same priority. And then less priority, we have the plus and minus. Okay, so why this is, so the unary is first and then come this and then come this. So why this is important? Because we want to know how to compute this expression. So if you write this in the code, so the computer first will evaluate this one first, 2 multiplied by 2, because it have higher priority, because multiplication is more important than plus or minus. So we'll evaluate this. This will be 4. So it will be 2 plus 4 minus 2. So we have a plus and minus. So we will evaluate the plus first because they are from the same level, but the plus is in the left. If we have two operations from the same level, we start left to right. So 2 plus 4 is 6. And then we have the minus. 6 minus 2 is 4. So first we have to do the multiplication and then the plus and minus. So it will be 2 plus 4, which is 6. 6 minus 2 will be 4. So here are some examples. Here we have to do the multiplication first. 2 multiplied by 4 is 8. 5 plus 8 is 13. Here we have to do the division first. 10 divided by 2 is 5. 5 minus 3 is 2. Here we have to do the multiplication first. 12 multiplied by 2 is 24. 8 plus 24 is 32. 32 minus 4 is 28. Here we have to make the modulus first. 17 modulus 2 is 1. The remainder is 1. 4 plus 1 is 5. Minus 1 is 4. Here we have to do the multiplication first. 6. So 6 minus 6 is 0. Plus 7 is 7. Minus 1 is 6. Sometimes you can enforce some operation to be first by using the parentheses. So for example here, 2 multiplied by 2 is more important because it's multiplication. So it's 4. 2 plus 4 is 6 minus 2 is 4. But if you make parentheses here, you need to evaluate the parentheses first. So 2 plus 2 is 4. And then 4 multiplied by 2 is 8. 8 minus 2 is 6. If you put the parentheses here, you have to evaluate this first. 2 minus 2 is 0. And then 2 multiplied by 0 is 0. And 2 plus 0 is 2. If you make parentheses here and the parentheses here, then you evaluate this one first. 2 plus 2 is 4. Multiplied by 2 minus 2 is 0. 4 multiplied by 0 is 0. So using parentheses, you can force some operation to be evaluated first. This is example. Here we start with the parentheses. 5 plus 2 is 7. multiplied by 4 is 28. Here we start with parentheses. 5 minus 3 is 2. 10 divided by 2 is 5. Here we started with parentheses. 6 minus 2 is 4. So this is 4. And then we started with multiplication because it's more important than plus. 12 multiplied by 4 is 48. Plus 8 is 56. 4 plus 17 is 21. This is we started first, 21. 21 modulus 2 is 1. 1 minus 1 is 0. And here this parenthesis is 3. This is 9. 3 multiplied by 9 is 27. Divided by 3 is 9. So you have to be careful when you write the code. You cannot write area equal LW, length multiplied by width. The code will not accept this, the compiler. He needs to write star. So you cannot write LW, which means L multiplied by W. Also, like in the power, you need, if the area is S to the power of 2, you need to write power S2. Bow S2. So this is a function that we use to compute the power. There is no operator for the power. Sometimes if you want to rewrite this as equation or assignment statement, so you need to do parentheses because you need to compute y2 minus y1 divided by x2 minus x1. So for example, 6b, we will write it 6 multiplied by b. 3 multiplied by 12, we will not write it like this. Like this, it's accepted mathematically, but in code, you have to write it like this. Same thing here. For xy, you need to write 4 multiplied by x multiplied by y. So what if we have mixed types? So if you have operation with mixed type, like 5 plus 3.5, what we will do, so some operation have to be converted to another type. Some of the types we need to be converted into other types. How we convert types? So types can be converted in some order. Like for integer, can be converted to unsigned integer, which can be converted to long. Long can be converted to unsigned long, and so on. Unsigned long can be converted easily to float. Float can be converted to double. Double can be converted to long double. So this is called like promotion because we are converting the higher. And we can also convert from higher type to a lower, which is called demotion. So by default, character short, unsigned short are promoted into integer, int. And if you are operating with a different data types, so the lower one will be promoted to the type of the higher one. Like imagine we have equation between 5 and 3.5. 5 is integer, 3.5 is double. So we will change the integer to double because double is higher than integer in this hierarchy. So we will change this integer into double so that both are double, and then we perform the operation. When using the assignment operator, the type of the expression on the right will be converted to the type of the left. Like if you have a double, x equal 5. So 5 will be converted into double first before we assign it to the variable. We have something called overflow or underflow. The idea, if you have a variable and you try to store a value that is more than the capacity of this variable, you have something called overflow. So overflow, some systems maybe give you error message. Some system will stop the problem, and some system will not stop the problem but will give you incorrect result. So you have to take care when you store a value in a variable that this value is within the range of that data type. We have something called typecasting. So how to cast? Cast is to convert from one type to another type. Imagine I want to compute y2 minus y1 divided by x2 minus x1. So imagine all of these variables are integer, so the result will be integer, right? But imagine I want to know the result exactly, like not as integer, as a double. So in this case, you make static cast double for this. So this is integer, but it will be converted into double. So static underscore cast double will explicitly change this value from integer to double. So if it was 5, it will be stored as 5.0, something like this. So useful to see integer of value of a character. So if you store character C, if you print this character directly, you will get C. But if you want to know which what's the integer code for C, you just write static cast int, yani change this variable into integer, so that, and then print it. Before you print it, change it into integer, so this will print the code of the C capital. So this is example. We define book, we define month, and we define double per month. How many books you plan to read, and we see in book. So let's say he enter 30. How many months you will need to take them? Month. He enters 7 months, so he will borrow 30 books for 7 months. We want to compute how many books he read every month. So we have to divide books divided by month. But if you divided books by month, you will get integer value. But we don't want integer value, we want a double value. So in this case, you need to write per month equal static cast double box divided by month. Like change box into double first and then divide it by month, so that you will get a double value in the output. So when we print it, we will get double value. If you didn't write this, you will get only 4. So it will be 4, and when you store 4 in per month, it will be stored as 4.0. So you will lose the fraction. If you don't want to use the fraction, first convert box into double and do the division. So in the previous C++, the casting was done like this. You write the data type between 2 parentheses, and this will change the character into integer. Okay. In pre-standard C++, it was like this. You write the data types and then you write 2. Both works for the current C++, so both are still supported in C++, but static cast is preferred. So we can do cast in 3 ways. Static cast, or in like this, or like this. All of them works. So if you want multiple assignment, what's multiple assignment? This is usually, we don't use it a lot, but if you have x equal to y equal to z equal to 5, this we start from right. So z will be equal to 5, and the result of this is also 5. It will be stored in y as a 5, and the result of this is 5, so it will be stored in x as a 5. So this will store 5 in z and y and x in conclusion. We have some statement like this: sum equals sum plus 1. This means like add 1 to the value of the sum. So if the sum, the previous value of sum was 5, it will be 6 after this statement. So 5 plus 1 is 6, and 6 will be stored in sum and will replace the previous 5 in the sum. So this will add 1 to the variable sum. X equal x plus 4 will add 4 to the value of x. So this adds 4 to x. So if x was 6, it will be 10. X equal x minus 3, it will subtract x3 from x. So if x was 6, the new value of x will be 3. X equal x multiplied by 10, it will be 60. X equal x divided by 2, so x will be 3. X equal x modulus 4, so x modulus 4, 6 modulus 4 is 2, so the new variable will be stored 2. So there is another way to write such a statement: sum equals sum plus 1. You can write sum plus equal 1, which means add 1 to the sum, or which mean like sum equals sum plus 1. Same way, like sum plus equal 5, this statement means x equals there is assignment operator x plus 5. X minus equal 2 means y equal y minus 2, and so on. So we can write them, if we have the variable here and here, you can just make a shortcut, c modulus equal 3, and so on. So this was for today, and see you in the next video.